So welcome to our talk entitled Feedback on Student Programming Assignments, Teaching Assistance versus Automated Assessment Tool. And we would like to report on a controlled experiment that we did at the IT University of Copenhagen, and we are Nynne Gauslund Christiansen, Sebastian Matthäus Nikolajsen, and myself, Claus Brabrand. So let's have a look at the outline for the talk. So first, we'll look at introduction and motivation. Then we're going to consider the experimental setup for our controlled experiment. Then we're going to look at the results, and we're going to do this in two parts. So first, we're going to look at task effectiveness, and these are essentially based on objective metrics. Then we're going to look at subjective metrics, looking at student perspectives. And then we're going to consider threats to validity. Hereafter, we're going to look at the conclusion, and again, we're going to do this in two parts. So first, we're going to look at a cost-benefit summary of our results, and then this leads to 4 recommendations. So from manual to automated assessment, universities are increasingly adopting automated assessment. So automated assessment tools, or AATs, as we're going to abbreviate them in this talk, adopted instead of teaching assistants for providing students with feedback on their programming assignments. So there might be many reasons for this, one of which is that replacing TAs with AATs provides scalability by reducing the per student costs. Now, however, there's limited research on the pros and cons of replacing TAs with automated assessment. So for instance, or in particular, what is the effect on task effectiveness, and what is the effect on student perspectives? And we performed a controlled experiment involving 117 students to investigate this. So if we look at manual assessment over here, and we plot on the other end automated assessment, again, if we plot on the orthogonal axis here, we plot rich feedback, and down here, limited feedback. Indeed, our teaching assistants would reside in this corner, manual feedback and rich feedback, and we instructed our teaching assistants to just provide normal feedback for the experiment. So for the experiment, we decided to compare the extremes of the spectrum. So by taking automated assessment tool, we took CATIS here, which has been in use at our university for a number of years, and we deliberately configured it to give only limited feedback, again, to test the more extremes of the spectrum here. So we have 2 research questions. So the first is in terms of task effectiveness, RQ1. How do teaching assistants and automated assessment tools compare for providing feedback on student programming assignments in terms of task effectiveness, such as correctness, duration, and code smells? And these constitute the objective metrics. So for the subjective metrics, we investigated student perspectives. And our second research question says, how do teaching assistants and automated assessment tools compare for providing feedback on student programming assignments in terms of student perspectives, such as frustration, unmet assistant needs, and preferences? And these were the subjective metrics. So the potential participants for this experiment was a cohort of 153 introductory programming students, and these were first semester students on their Bachelor of Software Development at the IT University of Copenhagen. So they had, in their first semester, they have CS1, aka Introductory Programming, which is a 15 ECTS course, and simultaneously with this course they will have a discrete math course and a course entitled Project Work and Communication. And these 2 other courses together also account for 15 ECTS, so hence the size of these 2 courses is comparable to the size of the 1 introductory programming course. So in terms of the composition of students, there were 20% of these students are women and 80% are men. And in terms of prior programming experience, 33 self-reported that they had little to no prior programming experience before starting the course, and 45 had some prior programming experience, and 22 reported that they started with prior programming experience. So on the day of the experiment, we see that 117 students participated, and of these, about 21% were women, and 38% of those were inexperienced or had limited prior programming experience. So the task used for the problem here is the FizzBuzz problem, which is frequently used by the tech industry recruiters. And the task is to output the first 1,000 integer numbers consecutively starting from 1, but where each number divisible by 3 is replaced by the word fizz, and each number divisible by 5 is replaced by the word bus, and each number divisible by both 3 and 5, so hence divisible by 15, is supposed to be replaced by the word FizzBuzz, hence the name of the problem. And then also counting has to restart from 1 every time the count hits 100. So here are the first many numbers of the problem. So we start with 1, 2, and then we have 3, which is divisible by, well, obviously 3. So instead you write fizz, then 4, and then buzz, since this number is divisible by 5. Again, 6 is divisible by fizz, by 3, so we write fizz. Then we have 7, 8, fizz, buzz, 11, fizz, 13, 14. And then we have a number here divisible by 15, so we write FizzBuzz, then 16, and so on. So, this is translated, so in Danish this is known as the Øf-grønt problem, but is otherwise completely similar. And the students had 1 hour to complete this problem, and we ended up giving them an extra 10 minutes, so they had 70 minutes for the problem. So here's a solution actually provided by kindly by ChatGPT. So we see an iteration here that maintains the number and all in question, and also a count in order to be able to restart the counting. If the count hits, or if the number hits 100, we restart counting. And if I is divisible here by 15, we output FizzBuzz. If the number is divisible by 3, fizz, and if the number is divisible by 5, we output bus, and otherwise we output the number. So this is to give you an idea of the complexity of the task. So if we look at the conditions here, we had 117 students which were randomly assigned to one of 3 conditions represented by one of 3 rooms. So here we have the first room, or the first condition here, which is called TAs, wherein teaching assistants are available for questions and feedback on the programming task. So here we had a male and a female teaching assistant, and 39 students were randomly assigned to this condition, where they could ask the TAs for feedback or ask questions. Another condition over here is the AAT for automated assessment, and here automated assessment in the form of CADIS was available for the students. So we had 42 students here with access to CADIS on their computer. And the last condition here is the combined effect of manual and automated feedback. And in this condition, students would have 2 TAs available, and they could also use CADIS. So then we had 36 students randomly assigned to this condition here. If we look at the structure of the conditions, we have teaching assistants here, and we have automated assessment here, and we have the combined condition up here with access to feedback from both manual and automated assessment. So one of the reasons for structuring it like this is that these 2 conditions, they attest to the effect of having TAs, irrespective of having an automated assessment tool available. And symmetrically over here, these 2 conditions account for the effect of having automated assessment, irrespective of having a TA present. If we look at the results of our controlled experiment, first we look at the results for RQ1, so in terms of objective task effectiveness. If we look here at the TA's condition, so we see that this number here represents the ratio of students, the relative number of students scoring 0 here, about 40%, and over here on the other end of the spectrum we see about 1/3 of the students scoring 100% on the test here. If you look at the results under the automated assessment, we see that the results move in the direction of more correct, and even more so when the students have access to both manual and automated feedback. If we compare these two, so that's TAs against automated assessment and TAs, we see a statistically significant difference. So students with access to feedback from both TAs and automated assessment make significantly more correct solutions than those students with access to feedback from only TAs. If we look at the second metric here, duration, here is the distribution of the finishing times for students with access to feedback from only TAs. We see a median of about 50 minutes. We see the time dropping when students have access to instead only automated feedback, and it drops even further here if we look at students having access to both manual and automated feedback. Again, if we compare the two extremes here, we see that students handing in the final submission with access to feedback from both TAs and AAT are significantly faster than those with access to feedback from only a TA. And the results is statistically significant, as we can see over here. For code smells, if we have a look at this students under the TA condition here, we see here students that hand in code that has 1 to 4 code smells. Over here we have students handing in code with 10 or more code smells. We see the numbers improving when we look at students with access to automated feedback, and again improving even further when the students have access to both manual and automated feedback. Again, if we compare the two extremes, we see that students with access to feedback from both TAs and automated assessment write code with significantly fewer code smells than those with access to feedback from only a TA. If we look at now, in order to ensure that non-dominant subgroups are represented and not simply diluted into our data, we consider two minorities. So we look at women. And we get similar results for the first research question for all three metrics when we project onto the 25 women that participated. Again, similar pattern emerges if we project onto the students without prior programming experience. Now, if we look at the second research question, subjective student perspective, things change. However, so for RQ2, this was another story. We found massive gender differences for this second research question, and much less differences in terms of prior programming experience. So we have split the data now for gender. So if we look at frustration, here are the results of self-reported frustration during the experiment, and we asked the students to rate it on a scale of 1 to 5, where a rating of 1 would correspond to no frustration, and 5 would be maximum frustration. So here are the results for the women, and we highlight the higher levels of frustration here to make it more easily visible. If we look at the results for the men, we immediately, if we compare these two, see that there is a gender signal here. So women are in general significantly more frustrated than men when solving the CATAS problem, independent of the form of feedback. So the results are simply that women are more frustrated up here. Now, if we compare the students with access to only automated feedback, so under the AAT condition, if we compare that to students having access to possibly also a human, we see also that there appears to be weakly significantly more maximally frustrated students under the AAT condition than under the other conditions, and this is weakly significant. If we look at assistance, which is quantified as the unmet assistant needs, again on a 1 to 5 scale, So a 1 means that you don't have any further assistant needs, and 5 is that you felt that you have maximally number of unmet assistant requirements during the experiment. Here are the results for the women, and again here are the results now for the men. So we see a difference. So if we compare the women to the men, we see that women in general report significantly more unmet assessment needs than men. And if we zoom in on the elephant in the room here, we look at women under the AAT condition, so with having access to only feedback from a computer, we see, and compare this to the other conditions, we see that the unmet assistance needs for women here with feedback from only a computer compared to the other conditions is also strongly statistically significant here. So in terms of preference, we ask students what they would prefer, if they preferred having feedback from a human TA, if they didn't have any preference, or if they preferred having automated assessment or feedback from CATIS here. If we look at the results for women, we see that women in general prefer feedback from a human, not a computer. So indeed the results here are more women prefer having feedback from TA. Some have no preference and few report preferring CATIS. If we look at the results for the men, we see in contrast that men, they as a whole don't really care if it's manual or automated feedback in this case. For the threats to validity, in the paper we consider conclusion validity, so the fact that the study is based on only one task, internal validity, correctness, whether or not it's biased towards automated assessment, whether or not the students understood the role of the TAs, whether the students interacted, we asked them not to, and also the comparability of the TAs, and whether or not there were any differences attributable to this experiment taking place in 3 different rooms. In terms of construct validity, we ponder how duration was measured and how gender was measured. And for external validity, we consider the results beyond CATIS, beyond simple programming tasks, and beyond a lab setting, and finally beyond software development. And for all of these, please consult and possibly even cite the paper. Now for the conclusion, if we look at the cost-benefit summary here, here are the costs in terms of resources, and if we measure this in terms of time or effort it takes under the TA condition, we will have some number proportional to the number of students. For automated assessment, there is a constant cost, and ideally, of course, this is independent of the number of students. For the both conditions, this is obviously the sum of these two. If we look at the asymptotic complexity of this, obviously for TA condition, this is linear. The cost is linear in the number of students. The cost under automation is constant. And again, the combined cost over here for the both manual and automated assessment is linear in the number of students. If we look now at the benefits for research question 1, we saw that the worst condition was having access to only feedback from TAs, and the best condition was having access to both a human and a computer. And for the RQ2, we saw that the worst of the conditions was automated assessment alone, and the best one was having access to both manual and automated assessment. This leads us to 4 recommendations. So if we plot along the vertical axis the number of students, and along the horizontal axis the number of resources per student, if we look at, if you have a lot of resources, you would want to provide both manual and automated feedback. If you have only, if you have few resources and few students, you may want to provide only manual feedback from possibly a part-time TA, and eliminate the overhead cost of automation. And then universities with many students and few per student resources may be tempted to provide only automated assessment. But here we would advise a word of caution is that our results show that this is not ideal, in particular for women. And we would propose a fourth option, which we label a scalable compromise, which is to provide automated feedback to everyone and then manual feedback from a very limited pool of TAs to only the most struggling of students in need. And this concludes our talk. So thank you very much.